So now in this video we have a couple of MOSFET transistor. One of them is N channel right there, and then one of them is P channel right there. So we have a signal, a high signal. The output is actually low, so the blue LED is lit up, and we can give it a stray signal so it can bounce around, but it will mostly lock in place once I release. But in any case, so we had a positive supply, the output was low, blue, and now to the negative supply right there. Now we have the red LED lit up, which means we are powering it from the positive supply, even though the jumper is to the negative supply. So the way that this works, first off, we have the P channel enhancement mode MOSFET right here, the BS250. It's in the E-line package. The front of both of them are facing the LEDs, because you can see that their drains and sources are on opposite side. So you can line them up so that their drains are directly together. I have a jumper tying their gates together. A little jumper is coming from the output to the LEDs. But in any case, the gates are tied together, and I got a jumper in one of the slots that we can go to the positive supply. So when that happens, both gates get more positive. But the P channel enhancement mode MOSFET, I'm using the BS250 and E-line package right there. When the gate's more positive, the channel is more negative, it doesn't conduct. It's a P channel enhancement, so you want the channel more positive. Whereas the N channel enhancement mode MOSFET, again, gate more positive, that makes the N channel more negative, and it conducts better. So we have that current path for the blue LED to light up, actually the opposite of what we have right there, but you can see the current path. Now if we move the jumper to the negative supply, which we have right now, both gates become negative right there. Both channels become positive, so the N channel stops conducting, whereas the P channel enhancement mode MOSFET, when its channel is more positive, it conducts really well, and the red LED lights up. And we are using 5 volts. Red LEDs are not as bright as blue LEDs, so I have a 200 ohm resistor limiting current for it. And the blue LED, it's brighter with the same amount of current, and so I have a 1000 ohm resistor protecting it. So now we'll get a closer look at the physical circuit. 1000 ohm resistor, long lead anode, short lead cathode for the blue LED comes to that jumper, and then so that lights up when the output is low right there. Then we have the red LED, it lights up when the output is high. So got long lead anode there, 220 ohm resistor as I said before, and next to them, in case you couldn't see it, we got the jumper coming to the drain of both transistors right there. The middle pin for both of them are a couple spots away from each other, so I have that blue jumper going to those 2 spots. You can see we got a middle there where their drains are connected, and so it doesn't matter which side I put the jumper there, that gives us their signals to the both of them. And then the far end of each of them, because the fronts are facing to the right, the E-line package front is smaller, TO92 package front is larger. But in case we got the source to the N channel enhancement mode MOSFET 2N7000 BS250 up here, we have the source going to the positive supply. And so right now the gate signal is low, but the red LED, as we said before, the output has to be high for that to light up. And then right now when they're both glowing, that is because my body can provide alternating current right there. It's going back and forth due to electromagnetic waves from the power around me, hitting me from the house. And there we go. So high input, and so that's high there, so you know that the other side of the LED goes to ground.